Greetings for the day. Welcome to the video lecture. So today we'll be dealing with basics of leveling. My name is Pradyut Anand. I'm an assistant professor in the Department of Civil Engineering at Madanapalli Institute of Technology and Science. So in today's lecture, we'll be going with the following contents. So we'll be dealing with introduction of leveling. We'll be dealing with types of leveling instruments, the basic concepts that are related to the leveling, height of instrument method, problem on height of instrument method, rise and fall method, problems on rise and fall method, the practical applications of the leveling, and the concluding slide, what we all learned in the basics of leveling concept. So let's start. So what is leveling? Leveling is basically determining the height of one level related to another. Basically, it is a comparison of 2 points, whether a point A and point B, which one is at a higher elevation compared to the other. Why it is crucial? It is crucial in various fields such as during the construction activities, engineering activities, and landscaping. While, for example, if we are designing a drainage, then one end of the drainage should be at a higher elevation as compared to the other so that the proper flow of the drain is maintained. So leveling is very important. Now, what is the purpose of leveling? There are basically two purposes of leveling: establishing points at the same height and also determining the height difference. So establishing points at the same height ensures a consistency in elevation across the project. Like when with respect to a known point, we are establishing the other points. So we know that the point B, C, D, E, for example, is at what level compared to point A. Similarly, determining the height differences. So as I said, we should know that what is the elevation of a particular point on the landscape. Suppose we have to construct a house, so it will require columns. Now, if the height of the column as suggested by the engineer is 3 meters. Now, if one point on this landscape is at a higher elevation as compared to the other, then to maintain that 3 meter of column is not possible. We have to end the column at the same level so that the first flow that comes on the column is uniform. That is why determining height differences is very important. So, types of leveling instruments. So, leveling requires a number of instruments. One of it is the optical level, then a leveling staff. And what is an optical level? So, optical level can be of three types, that is dumpy level, auto level, laser level. A dumpy level is a traditional optical instrument for precise horizontal plane measurements. An auto level, it is basically this automatic version of a dumpy level. It automatically maintains the horizontal line of sight and it is easier to use. Laser level, similar to auto level, but in this, the line of sight is projected as a laser. Then, as I said, leveling staff is also one of the important instruments. So, when we are seeing through the optical level, we through the line of sight, we see one graduated scale presented at one point. At that point, we keep that leveling staff and we take the reading, which helps in determining the height of that point through various calculations that we will discuss later. And a tripod stand. A tripod stand is basically used to hold the optical instrument. So let's start with the basic concepts. So datum. A datum is a reference point on the Earth's surface with known height. A datum is very important in terms of leveling. As we all have known, we know that mean sea level, that is for India, it is located in Bombay. So that mean sea level is basically a reference point. Now datum is and it is a known fixed point for everyone. Now any part of the India, when if we are comparing that at what elevation we are, we say we are at 500 meters above the mean sea level. We are 10,000 feet above mean sea level. So this is based on the reference point, that is datum. Then benchmarks. Now benchmarks are basically fixed reference points with known elevations used throughout a survey. So if we are conducting a leveling leveling program on a landscape, then what we do, we fix a known benchmark that acts as a datum for that particular area, and and compared to that, all other points are taken. Reduced level. So it is basically the height of a point relative to the datum. So suppose I've marked point A as a benchmark, that is datum for that particular area. Then if the height of the point B, C, D will be basically their reduced levels with respect to datum, that is benchmark of that particular area. Now, the different types of leveling. So we have three types of leveling: simple leveling, differential leveling, profile leveling. Simple leveling. Simple leveling is basically determining the height difference between 2 points. Differential leveling. It establishes the elevation of a point relative to another. But it helps in establishing the height of point B with respect to point A. Profile leveling. It determines elevation along a fixed line. So, for example, simple leveling is basically just to know what is the difference in height between point A and B. Differential leveling helps in managing the site. Suppose we need to, as I gave the example, if we need to construct a house, we would mark the location of the columns. Now, those columns will, if the ground is not an even surface, then we have to mark the elevation of the columns with respect to the benchmark, and for that we will design the columns, the height of the columns, and also the reinforcement in the columns based on the total area of the column that we are taking. And profile leveling is also same as differential leveling, but it is a continuous process along a fixed line to have a straight path of fixed elevation. Height of instrument method. Now, in the contents we saw that there were two methods, but one was height of instrument method and one was rise and fall method. Now these two methods are used to calculate the reduced level of a point. So let's first discuss with height of instrument. The height of instrument method involves calculating the height of instrument above a datum to determine the heights of other points. The procedure for it will be, we will first set up the instrument and take the backside reading from a known point. Now, what is backside reading? So, backside readings are basically the reading taken through the optical level at the at a point where that leveling staff has been kept. Now, if a series of readings are going to be taken, the first reading that we take by setting up an instrument is the backside. Then second step is to calculate the height of instrument by adding the backside to the known elevation of the point. So the known elevation will be the datum that we have transferred to the point, or the benchmark that we have transferred to the site, with respect to which the other points will be taken. So height of instrument will be backside plus RL. Then after that, the third step is taking all the foresight readings at other points to determine their elevation by, and the procedure to do is by subtracting the foresight that comes from the height of instrument that we have calculated. Let's see a very simple problem on this. So as we see, the problem states that we should determine the elevation of point B given the elevation of point A, which is also the datum, which is 100 meter. The backside reading taken at A is 1.5 meter. The foresight reading at B is 2 meter. So since there are only two readings were taken, so the first reading is the backside and the last reading is the foresight. Now, first step is to take the backside that has already been given. Now we need to find the height of instrument. So height of instrument, as I said, it is basically the sum of the benchmark or datum plus backside. So 100 plus 1.5 meter gives 101.5 meter. That is the height of instrument. Now we have to establish the elevation of point B with respect to point A using height of instrument method, which will be done by the simple method that, as said, the formula is the height of instrument minus the foresight reading taken at point B. So it is 99.5 meter. So we see that the point B is lower as compared to point A. Point A is at a higher elevation as compared to point B when we calculated the elevation of B. Now let's go with the rise and fall method. So the rise and fall method also calculates the difference in elevation between the consecutive points and helps us in determining the RL of a point. The procedure in this is, we we don't take readings at one point. We take readings at several points, then we divide it into the different sections, that is backside, intermediate side, foresight, and then we calculate continuous rise and fall comparing the two levels. Suppose we have taken 10 readings, then we will compare the rise or fall between point 1, point 2, then between point 2, point 3, then between point 3, point 4, and so on. Now let's see the problem. So here, as the problem states that determine the elevation of point B and C given the elevation of point A, that is 100 meter. The readings at point A, B, and C are 1.5, 2 meter, and zero point 0.5 meter. Now, as I said, the point A, B, and C. So three readings have been taken. So the first reading would be called a backside. The last reading will be called a foresight, and the any other reading that will be taken between backside and foresight will be intermediate side. That is at point B. So rise and fall, as I said, we will compare all the three points, that is A, B, B, and C, like that. So the rise or fall from point A to B is calculated by taking the difference between the readings. So as we see, 1.5 meter minus 2 meter is the as the readings taken at point A and B. That gives us a zero point 0.5 meter with a negative. What does negative means? Negative means a fall. This means that the point B is at a lower elevation as compared to point A. If the same reading would have been a positive, then it would have been a higher elevation. Let's, as we see, from point B to C, we get a value of plus 1.5 meter, which is a positive value, which means that point C is higher as compared to point B. Now, once the rise and fall have been found out, the elevation of B and C can also be found out simply by by adding the rise or fall from point A to B to elevation to the RL of point A, that is RL of the previous level. So for A, we have been given 100 meter as the datum level. So 100 meter with rise and fall. So we got a fall of zero point 0.5 meter between A to B. So 100 minus zero point 0.5 will give a 99.5 meter. So as I said, this is at the lower elevation as compared to A. But elevation of C, it is 99.5 plus 1.5, 101, which says that it is 1.5 meter higher as compared to point B elevation. So these are two simple problems or simple methods by which we can calculate the leveling at a point. Now let's see the practical applications. So a practical application of leveling is, we can say, in a day-to-day life, leveling a garden plot. So what we do, we identify the high and low spots. We try to even these spots, because if rain comes or some waterlogging happens, then it could lead to disturbance. So we try to either have a profile level where the water could flow easily, and we do, or for beautification purposes as well, if we want to keep some pots at a higher level, then the a set of pots just below it, we need, what we do, we either put bricks or sand. We make that point higher as compared to the lower. So it is basically leveling only in day-to-day life. And second application will be leveling for installing a shed. So a shed also works on the same purpose. That shed should be should be at a level such that the rainwater disperses easily and no accumulation of water on the shed take place. Similarly, leveling a driveway. So a driveway also serves the same purpose. Like at one end should be higher as compared to the lower end to maintain a slope and um, provide a smooth surface for water passage. So let's see what we all have studied today. So we have understand what leveling means. So leveling is essential for accurate horizontal and vertical measurements because it is a comparison between 2 points. Then we have seen what all instruments are required to perform leveling. Then we have seen the two different methods, that is height of instrument method and rise and fall method, to perform leveling. Then we have applications. We have discussed the applications as like how to during laying of a shed or in leveling the garden plot. These applications, these are practical applications of the leveling in day to day life. You do not want required to be a civil engineer to perform leveling. Every day someone is performing these leveling method in a day to day life. So these are the references for today's work. You can give the feedback on this form. Thank you.